Welcome to the class of fluid mechanics and hydraulic machines. Today we are going to discuss about the open channel flow. What is open channel flow? Open channel flow, it can be defined as the fluid flow, that is maybe the water or other fluids. It may be through the conduit or out of the conduit also. It should have a free surface subjected to atmospheric pressure. That is the important. That means it should have a free surface that is subjected to the atmosphere. Like you can see here, you can imagine the flow in the rivers, flow in the canals. This is the flow. Suppose this is the flow. The top surface. This is the top surface of the flow which is flowing. This top surface, above the top surface there is the atmosphere. That means the top surface is subjected to atmospheric pressure. So this type of flow is called the open channel flow, in which the top surface should be subjected to the atmospheric pressure. Now take the example of the pipeline. If the pipeline is there and flow is flowing in the pipe, and the flow in the pipe is up to completely not filled, that is the fluid is not completely filled in the pipe. So, suppose up to here the fluid is filled. That means fluid is partially filled in the pipe and flowing. So this is the top surface layer of the fluid in the pipe. It is partially filled. That means above this and between the above this top surface and between this, that is between the top surface and this is the boundary of the pipe. In between gap is there where the atmospheric pressure exists. So that means on the top surface atmospheric pressure is existing. So this flow also comes under the category of open channel flow. That is the flow in the conduit or flow in the canals, rivers, streams, in which the flow, that is the top surface of the flow, is subjected to the atmospheric pressure. It's called the open channel flow. That is the definition for the open channel flow. Example is given: river flow, partially flow in the closed rivers, partially flow in the closed irrigation ditches. These are comes under the category of open channel flow. This is the examples given. This is the suppose flow direction. This is top surface is subjected to the atmospheric pressure. Here also this is the flow in the canal. Top surface is subjected to atmosphere. So both comes under the category of the open channel flow. And this top surface is called the free surface. This top surface is called the free surface as there is no pressure apart from the atmosphere. So only the atmospheric pressure is there. That's why it is called the free surface, as there is no other pressure. This is called the free surface. That is, the free surface is the surface on which atmospheric pressure is exist only. Now the flow classification. Various type of flow is there. Based on the time, it can be steady, unsteady flow. Based on the space, it may be the uniform, non-uniform. Based on the Reynolds number, it may be the laminar, it may be the turbulent. Based on the Froude number, it may be the subcritical, critical and supercritical. We will see one by one each. Based on the time, it may be the steady, it may be the unsteady. So flow is defined by some characteristic, that is the flow characteristics: depth of flow, velocity, discharge. These are the flow characteristics. If the flow parameters, flow properties, that is the depth of flow, velocity, discharge, these are not changing with the time at any given location. If these are not changing with the time at any given location, then it is called the steady flow. If the flow, suppose take the depth of flow, if the depth of flow is not changing with the time at any given section, suppose this is the channel bed. Take this section 1. At this section, if the depth of flow at time t1 is d, at time t2 again at this section the depth of flow is d, and at time t3, maybe 2 days after, maybe 2 hours after, depth of flow is d, then it is called the constant depth, that is the depth is not changing with the time at a given location. So it comes under the category of steady flow. If the depth is changing, suppose this is section suppose 2, if the at t1 time this is the depth d1, at t2 time depth is d2, and t3 time depth is d3. So with the time at a given section, depth of flow is varying, so this is called the unsteady flow. So when the flow, depth of flow or velocity or discharge is not changing with the time at a given section, that means it is constant. If it is constant, then derivative of that constant will be 0. So in case of the steady flow, debr h upon debr t, debr u upon debr t, debr q upon debr t should be equal to 0. That is the depth of flow h, which is not changing with the in respect of time, so h is constant, so derivative will become equal to 0. Similarly, velocity not changing with the time, so debr u upon debr t is equal to 0. Discharge also not changing with the time, so debr q upon debr t equal to 0. When this is not equal to 0, debr h upon debr t is not equal to 0, debr u upon debr t is not equal to 0, and debr q upon debr t is not equal to 0. That means these are changing with the time. So this is the characteristics for the unsteady flow. So in the steady flow, debr h upon debr t equal to 0, debr u upon debr t equal to 0, and debr q upon debr t equal to 0. While in the unsteady flow, debr h upon debr t, debr u upon debr t, debr q upon debr t should not be equal to 0. This is the steady and unsteady flow. Now, based on the space, the flow may be uniform, flow may be non-uniform. Uniform flow, that is the flow parameters like the depth of flow, velocity, discharges, this should be not change in respect of the distance for any given time. That means this is, suppose this is the channel, bottom, flow is there, this is the, suppose, depth of flow, upper layer. So take any section, this is section 1, this is section 2, section 3. So we can see a space, that means the distance, that means the at section 1, suppose distance, depth of flow is d1, at section 2 depth of flow is d2, at section 3 depth of flow is d3. So if the depth of flow is not changing, that means d1 equal to d2 equal to d3 or at these sections. At a given time, at a particular given time, if d1, d2 and d3 is equal at all the 3 sections, then you can say this reach is under the uniform flow condition. Uniform flow, that means the depth of flow or velocity or discharges is not changing at various sections for a given instant time. If this depth of flow, velocity or discharge changing with the time, then it is called the non-uniform flow. That means uniform flow, debr h upon debr x, here derivative of depth of flow in respect of distance x, derivative of velocity in respect of distance x, derivative of q, discharge, in terms of x, space. So derivative is 0, while in the previous case steady flow, in steady flow what is there? In steady flow, debr h upon debr t is 0, that is in respect of time that was 0. Here in respect of space it is 0, and if it is not equal to 0, that means it is varying, so it is called the non-uniform flow. If it is constant, it should be equal to 0, and then it is called the uniform flow. So the depth of flow, velocity or discharge is not changing in respect of the space for a given time, then it is called the uniform flow. If the flow depth or velocity or discharge is changing with the space for a given time, it is called the non-uniform flow. Now further, this non-uniform flow can be categorized into the three categories. One is the gradually varied flow, one is the rapidly varied flow, one is the spatially varied flow. So all these three flow are the non-uniform flow. That means the flow depth is changing with respect to a space. This non-uniform flow categorized into the three categories: gradually varied flow, GVF, gradually varied flow, RVF, rapidly varied flow, SVF, spatially varied flow. Gradually varied flow, what is RVF, rapidly varied flow, and what is SVF, spatially varied flow? In the gradually varied flow, flow depth changes slowly over a relative longer distance. So in the gradually varied flow, flow depth is changing but slowly over a relative longer distance. While in the rapidly varied flow, the flow depth changes rapidly over a shorter distance. In the rapidly varied flow, flow depth changes rapidly, quickly over a shorter distance. You can see the example here. This is the diagram given in the Chow book 1959. You can see here the sluice structure is there, open channel flow is there, this is the bed, this is the bed, this is the bed, and this black line is showing the top surface of the flow, the top surface of the flow. Sluice gate is there, flow is entering. Here the depth of flow is this much. After the sluice gate, depth of flow becomes very small. So before this structure and after this structure, there is the large change in the depth of flow. So here this region will come under the RVF, rapidly varied flow, as there is the depth of flow is changing rapidly from larger to a smaller one. After this section, you can see up to this section, up to here, the flow depth is here slowly increasing. There is the increase in the flow depth in a slower manner over this longer distance. That is the relatively. That's why the word is used relatively. So here the change in the depth of flow slowly occurs over a longer distance. So this region comes under the GVF, gradually varied flow. Again, here is the change in the depth of flow very rapidly. So it comes under the category of RVF. In the GVF, again you can see this is the region GVF, where the flow depth changes very slowly over this distance. So it is the GVF, gradually varied flow. Again, one structure is present, and because of that, there is the change in the sudden depth of flow from larger to a smaller one. So it comes under the category of the RVF, rapidly varied flow. After that, again there is the small change in the depth of flow over this distance. So it comes under the category of GVF, gradually varied flow. After that, fall is there, that is the because of the slope. So here is the change in the sudden depth of flow, larger to a smaller one, that is the RVF, rapidly varied flow. So simply, in the gradually varied flow, there is a change in the depth of flow slowly over a longer distance, while in the rapidly varied flow, there is a change in the depth of flow quickly, rapidly over a shorter distance. In case of the spatially varied flow, there is a change in the discharge because of the addition of the water or withdrawal of the water. You can see here the canal is there, one canal is there. You can see cut, one cut is there. Water is withdrawn from canal to the agriculture field for some irrigation purpose. So that means here at this section, water is withdrawing. So either the water is added or withdrawing. Because of that, before this section and after this section, there is a change in the discharge. So this type of flow is called the spatially varied flow, where the water is added or withdrawn along the channel ridge. That is the spatially varied flow. Already seen this one. Now based on the Reynolds number, the flow may be laminar, flow may be turbulent. The laminar flow, what is the character? First we see the how we can say the laminar flow in terms of the number, Reynolds number. So Reynolds number is the ratio of inertia force to viscous force, inertia force to viscous force, dimensionless number force. So ratio of inertia force to viscous force, it can be written as rho Vd upon mu or Vd upon nu. Nu is the kinematic viscosity, nu is the kinematic viscosity, while mu is the dynamic viscosity. Relation between the mu upon rho is called the nu, that is kinematic viscosity equal to dynamic viscosity upon density. So once you computed the Reynolds number based on these parameters known, if you know the parameter density of the fluid, viscosity, density of the fluid, flow velocity, diameter of the pipe, and this is the, in case of the pipe flow, diameter of the pipe you can take. In case of the open channel flow, it can be taken as the hydraulic depth. So that means you have to find out the Reynolds number if know the if know the like the few property of the fluid like the viscosity, density, and the dimension of the channel or pipe. So you can compute the Reynolds number. If the Reynolds number is less than 500 in the open channel flow, in case of open channel flow, it is called the laminar flow. In case of pipe flow, the Reynolds number should be less than 2000, then it is called the laminar flow. So what is the characteristics of the laminar flow? It is having the low velocity, high viscosity, and flow in the parallel layers. You can see here the laminar flow. Flow are in the streamlines are in the parallel to each other. Streamlines are parallel to each other, so it is called the laminar flow. In case of open channel flow, if the Reynolds number is more than 2000, then it is called the turbulent flow. In case of pipe flow, the Reynolds number should be more than 4000. So turbulent flow characteristics, it is characterized by the high velocity, low viscosity, that is the flow path is chaotic. You can see the flow streams lines are moving and crossing to each other, no parallel to each other. This is called the turbulent flow. So based on the Reynolds number, the flow may be laminar, flow may be turbulent. Now based on the Froude number, flow may be critical, flow may be subcritical, flow may be supercritical. If the Froude number is equal to 1, it is called the critical flow. If the Froude number is less than 1, it is called the subcritical flow. If the Froude number is greater than 1, it is called the supercritical flow. Fr represents the Froude number. And this Froude number, dimensionless number, this Froude number Fr is the ratio of the inertia force. You can write here. Fr, ratio of the inertia force to gravity force. So Fr equal to, you can write, this is V upon under root GD. Fr equal to V upon under root GD. V is the flow velocity, D is the diameter of pipe you can take in the case of pipe flow, and in case of the open channel flow, D can be taken as the hydraulic depth. So if you know the velocity and D, you can compute the Fr. If you compute the Fr, if Fr is equal to 1, then this Froude number is applicable in the case of open channel flow. So this is hydraulic depth we take generally this. So now you put the parameters V and D value, you will get the Fr value. G value is constant 9.81 in SI unit of meter per second square. So that means put the value of V, G, D, you will get the Fr. If you got the Fr, then match the Fr with the 1. If Fr is equal to 1, that is the Froude number is equal to 1, the flow is treated as critical flow. If the Froude number value is less than 1, it is the flow is called the subcritical flow. If the Froude number value is more than 1, if the Froude number value is more than 1, then it is called the supercritical flow. If the Froude number value is more than 1, it is called the supercritical flow. in terms of velocity, you can define V is the average velocity of the flow and Vc is the critical velocity. That means when the critical flow occurs, corresponding to that critical flow, the velocity is called the critical velocity. So if the average velocity is equal to critical velocity, the flow is called the critical flow. If the average velocity is less than the critical velocity, the flow is called subcritical flow. If the average velocity of the flow is greater than the critical velocity, it is called the supercritical flow. Some characteristic is there. In case of the subcritical flow, the flow velocity is generally low and the flow depth is high, while in the supercritical flow, flow velocity is high while the flow depth is low. And this critical flow occurs in between the subcritical to supercritical. That is when the phase is changing from subcritical to supercritical or supercritical to subcritical, phase is changing, then in between that critical flow occurs. For the example, we can see here one sluice gas structure is placed here, and before that this is the flow depth, and after the sluice gate this is the flow depth. So we can see here the flow depth is higher here, while after that flow depth is lower. So flow depth is higher. Generally when the flow depth is high, it is the subcritical flow. This is the region of subcritical flow. If you compute the Froude number in this region, you will get the Froude number will be less than 1. While after the sluice gate, the flow depth is small. When the flow depth is small, then generally velocity is high and flow is supercritical. If you compute the Froude number here, you will get the Froude number is greater than 1. So this region will come under the supercritical region. Again after that, some here formation of hydraulic jump is there and the flow depth becomes higher. When the flow depth becomes higher, then the region comes under the category of subcritical. So here the Froude number you will get the less than 1 in this region. So we can see here flow is changing, flow phase is changing from supercritical before the sluice gate to the supercritical. That before the sluice gate subcritical is there, and after the sluice gate it is the supercritical. So that is the in between that somewhere this here the critical flow will occur, and again after from supercritical to subcritical, that is there is a formation of the hydraulic jump, and here the flow is changing from supercritical to subcritical zone. So in between here supercritical to subcritical, in between this, it is in this region somewhere the critical flow will occur, takes place. So based on the Froude number, the flow may be the critical flow, flow may be the subcritical, flow may be the supercritical flow. So we have discussed about the fluid flow. First we defined the open channel flow, then we have discussed about the flow types, that is the based on the time it is the steady and unsteady flow, based on the space it is the uniform and non-uniform flow. Again non-uniform flow is categorized into the 3 category: gradually varied flow, rapidly varied flow and spatially varied flow. Based on the Reynolds number, flow may be laminar, may be turbulent. Laminar is having the characteristics of the flow lines are parallel to each other, while in the turbulent flow lines are crossing to each other. Based on the Froude number, flow may be the critical, subcritical and supercritical. If the Froude number is equal to 1, critical flow, less than 1, subcritical flow and greater than 1, supercritical flow. So this is about the types of flow. So for this session, thank you very much.